Welcome to G Fun Facts Online. Today, we're stepping into a crime scene of cosmic proportions. The victims are entire worlds, long dead. The evidence is a fine dusting of their remains. And the detectives are astronomers, pioneering a new field called exoplanetary forensics. By sifting through the skeletal remains of shattered planets, they are piecing together the dramatic lives and violent deaths of worlds beyond our own, and in doing so, catching a glimpse of our own solar system's ultimate fate. The key to this entire field lies with stellar corpses known as white dwarfs. These are the incredibly dense, Earth-sized remnants of stars like our Sun that have run out of fuel. The immense gravity of a white dwarf is so powerful that it should quickly pull any heavy elements down into its core, leaving a perfectly clean atmosphere of only hydrogen and helium. But when we look at them, we find something strange. A surprising number of these stellar embers, somewhere between 25 and 50%, are what scientists call polluted. Their atmospheres are contaminated with heavier elements like silicon, iron, magnesium, and oxygen. This pollution is the smoking gun. It's the telltale sign that a planetary system has been destroyed. The leading theory is that after a star collapses into a white dwarf, the gravitational balance of its remaining planets is thrown into chaos. Surviving giant planets can act like gravitational bullies, nudging asteroids and even entire planets from their stable orbits. These unlucky objects are sent careening towards the white dwarf. As they get close, the star's immense tidal forces shred them into a disk of dust and gas, which then slowly rains down onto the star's surface, polluting its atmosphere. This process, sometimes called necroplanetology, gives astronomers an unprecedented opportunity. By using spectroscopy to analyze the light from a polluted white dwarf, they can determine the precise chemical composition of the planetary debris. The white dwarf essentially acts as a cosmic mass spectrometer, allowing scientists to perform a chemical autopsy on a vaporized planet. This is something that's completely impossible with any other current technology. The forensic process is meticulous. First, they identify a polluted white dwarf by splitting its starlight into a rainbow of colors, which reveals the chemical fingerprints of different elements. Once they find elements heavier than hydrogen and helium, they know they have a crime scene. Next, using sophisticated models, they determine the exact amounts of each element. This gives them a chemical inventory of the shattered world. With this inventory, they can work backward to figure out the geology of the original planet. For instance, the ratios of magnesium, silicon, and iron can reveal if the body had a distinct core, mantle, and crust, much like Earth. One of the most exciting aspects is the search for the ingredients of life, especially water. Water molecules themselves would be ripped apart in the hot atmosphere of a white dwarf, but their presence can be inferred by detecting an excess of oxygen. If there's more oxygen than can be explained by rocky minerals alone, it's a strong sign that the original body was rich in water. This method has already found water-rich debris around several white dwarfs, suggesting that the delivery of water to rocky planets via asteroids, a process vital for life on Earth, is common throughout the galaxy. The discoveries so far have been startling. Astronomers have found evidence for planets with completely exotic rock types, forcing them to create new classifications like quartz pyroxenites and periclase dunites. These are compositions with no equivalent in our solar system. These alien rocks might dissolve more water or melt at different temperatures than Earth rocks, which would have profound implications for the development of oceans and plate tectonics on those worlds. This forensic evidence, combined with direct observations, has painted a vivid picture of how planets die. Let's look at a few case files from this cosmic morgue. The first scenario is stellar engulfment. As a star like our Sun ages, it will swell into a red giant, expanding hundreds of times its original size. Any planets in close orbits are doomed. Astronomers recently witnessed this in real time. A star 15,000 light-years away suddenly brightened, which was interpreted as the death cry of a Jupiter-sized planet plunging into its expanding star. We saw the initial flash of impact, followed by the glow of ejected stellar material cooling into dust. A second, more common death is tidal disruption. This is what pollutes most white dwarfs. A planet or asteroid that survives the red giant phase gets gravitationally nudged onto a collision course with the white dwarf. Once it passes a point called the Roche limit, the star's tidal forces overcome the planet's own gravity, and it is ripped to shreds. The James Webb Space Telescope has seen the chemical signatures of silicate grains, the building blocks of rock, in the resulting debris disks. A third scenario is a planetary smash-up. We've seen evidence of this around a star named ASASSN 21QJ. It first brightened in infrared light and then dimmed in visible light a few years later. The explanation? A collision between two ice giant exoplanets created a massive, glowing cloud of debris. This cloud then passed in front of the star from our perspective, causing it to dim. It was a rare, real-time glimpse into the chaotic violence of planetary systems. Then there's a slower death: catastrophic evaporation. Planets orbiting extremely close to their stars are subjected to such intense radiation that their surfaces are literally vaporized. They develop vast, comet-like tails of gas and dust. One such planet is losing so much mass that it's shedding the equivalent of an entire Mount Everest every 30 hours. It will be completely gone in a few million years. But not all planets are destined for destruction. Some are true survivors, zombie planets that continue to orbit their dead star. In fact, the very first exoplanets ever discovered, back in 1992, were found orbiting a pulsar, the collapsed core of a massive star that went supernova. It's almost certain these planets couldn't have survived that explosion. The belief is that they are second-generation planets, formed from the debris left over after the star's death. More recently, a Jupiter-sized planet named Hala was found orbiting a red giant that should have already expanded and swallowed it. One theory is that Hala is also a second-generation planet, formed after its host star merged with another star. All of this brings us to a sobering look at our own future. In about 5 billion years, our sun will run out of hydrogen and begin to swell into a red giant. This expansion will be catastrophic for the inner planets. Mercury and Venus will be engulfed first. Earth's fate is debated, but it's highly likely it will be swallowed as well. Even if it escapes, the intense heat will boil away our oceans and atmosphere, leaving a scorched, lifeless rock. The outer planets, however, will likely survive. As the sun sheds mass, its gravitational grip will weaken, causing the orbits of Jupiter, Saturn, Uranus, and Neptune to expand outward. They will continue to orbit the sun's remnant, a white dwarf, for billions of years. We know this is likely because we've already found a Jupiter-like planet orbiting a white dwarf in a very similar configuration. In this distant future, the surviving giant planets will reshape what's left of the solar system. Jupiter's immense gravity will perturb the asteroid belt, sending a constant barrage of rocky bodies careening towards our white dwarf sun. Our own dead star will become polluted with the debris of its children, just like the cosmic crime scenes we now observe across the galaxy. Exoplanetary forensics is a field still in its infancy, but it is already revolutionizing our understanding of how planets form, live, and die. By sifting through the ashes of these cosmic graveyards, astronomers are not just uncovering the stories of lost worlds, they are holding up a mirror to our own solar system, revealing the grand and often violent context in which our planet exists. Thank you for listening to Fun Facts Online.